All right, assalamu alaikum, everyone. Let's begin. So in our last session, we talked about arithmetic progressions, arithmetic sequence. We can also call it a sequence. What does this sequence look like? It's a sequence in which the difference between the terms is constant. So for instance, you could have something like this, 3, 7, 11, 15, 19, and so on. Now in this sequence, the difference between consecutive terms is 4. All right, so this is an arithmetic sequence. Now we need two things to describe an arithmetic sequence. One is the first term and the other is the difference. First term is represented by this letter A and difference is represented by the letter D. Difference is calculated like this, next term minus the previous term. This is what we talked about in the last session. Then we discussed a number of different things about arithmetic sequences. We talked about the term formula, how to find the nth term of an arithmetic sequence. We talked about this. Then we did a couple of examples on how to use that formula. Then we talked about the sum formula, sum of the first n terms. That looks like this. There's another form that we've got for this as well, and that is this one. So half n into a plus l, and also half n into 2a plus n minus 1 into d. These are two different forms. You mostly will be using this formula that you see on your screen right now, but sometimes you have to use this other formula as well, because it makes things quicker sometimes, and that is when the last term is given. So you only use this formula when you know what the last term is. All right, that's when we use this formula. That's what we talked about. Then we again did some examples. This was an important one. If you have to find sum of some terms in the middle, how do you do that? We talked about this in the last session as well. And at the end, we discussed this one important thing, and that is if you have 3 consecutive terms given in an arithmetic sequence, you can say the difference of the second and the first is going to be equal to the difference between the third and the second, right? Because differences are constant. So in that, using this, you could find any unknowns that you have amongst these 3 terms. If there's one, you could find that, right? If there's more, you'll have some more information given as well. So this is all that we did in the last session. Now today, what we want to do is we want to start with geometric progression. So this is the other type of sequence that you have in your syllabus. Now you haven't discussed this in O-levels as opposed to arithmetic sequence. This is something that you haven't done in O-levels. Now, how do geometric progressions look like? Geometric sequences look like? Let's take an example. Let's say you have something like this, 2, 6, 18, 54, 162, and so on. Now, try to figure out how the consecutive terms are related in this particular example. If you think about it, 2 multiplied by 3 is going to give you 6. All right. Similarly, 6 multiplied by 3 is going to give you 18. And 18 multiplied by 54 is going to give you, 18 multiplied by 3 is going to give you 54. And so on. So how can you find the next term in this case? You can find the next term by multiplying the previous term by 3. All right. So that is what is happening in this particular sequence. All right. This number that you see here is called the common ratio between these consecutive numbers. Okay, so if you were to, for instance, find the ratios of consecutive numbers, so divide 6 by 2, for instance, that gives you 3, 18 over 6, that gives you 3, 54 over 3, 54 over 18, that also gives you 3. So basically 3 is the common ratio between any 2 consecutive terms. All right. So how do you describe a geometric progression is, you say in a GP, in a geometric progression, the ratio between consecutive terms that remains constant. Right, so the ratio between consecutive terms in this case is 3. So it's 1:3, 1:3, 1:3 for all of them. So essentially what this means is you've got the same number being multiplied to get the next term. Remember arithmetic sequences, what used to happen here? You had the same number added or subtracted. In a geometric progression, you've got the same number multiplied. All right, sometimes you could have ratio like this as well, 1/2, for instance. So you could also call that division by 2, or you could say multiplication by 1/2. So in this case, you'll have something being multiplied or divided, right? So that's what is going to be that's what is going to be happening in geometric progressions. All right. Now, how do you describe a GP? Let's think about that. A geometric progression is defined by two things as well. Now, one thing is the same as what we used to have in arithmetic progressions. That's the first term. So you need to know the first term of the GP. And the second thing is common ratio. Right? That's this number 3 here, for instance, in this particular example. All right, so common ratio and first term. First term is denoted by the letter A, and the common ratio is denoted by this letter R. Now, how do you find ratio? Now, you should know exactly how it's found. So it's basically next term divided by the previous term. What that means is, if you were to take any two consecutive terms in the sequence, for example, if I were to take 6 and 18, you look at the term that comes later and divide that by the term that comes before. So in this case, your ratio is going to be 18/6. All right. So 18 comes in the numerator, the number that's coming afterwards, that comes in the numerator, and the number that comes before, that comes in the denominator. So this is how ratio is defined. All right. So now, just like arithmetic sequence, we need to know a few things about a GP. We need to know what the nth term of a GP is. All right. Let's think about that. Nth term of a GP. Tn equals AR raised to power n minus 1. This is the formula that we use for nth term of a GP, of a geometric progression. Remember what this stands for? This means the value that you have at the nth term, at the nth position, the value of the nth term. What is that equal to? That's equal to A into R raised to power n minus 1. It's pretty straightforward. The first term is A, but then the common ratio is R, right? So basically, in order to get the next term after A, you have to multiply by R. So the next term is going to be AR. And the next after that is AR into R, that's AR square, and then AR square into R, which is AR cube, and so on. So this is the first term, this is the second term, third term, fourth term, and so on. So if you had the nth term, if you look at the pattern, you'd have n minus 1 in the power, because when you had 4 here, you had 3 in the power. When you had 2 here, you had 1 in the power, and so on. So this is how the formula looks like. AR raised to power n minus 1. All right. So this is the term formula that we've got for a geometric progression. Okay. So if for example, I had a GP, if I had a geometric progression that looked like this, 2, 6, 18, 54, the expression that the sequence that I wrote above, if you had this sequence, now, if somebody was to ask you what the fifth term is, that would be pretty straightforward because you have 4 terms here. You could just multiply 54 by 3 and that would give you the fifth term. However, if somebody was to ask you what is the 10th term of the sequence, now for that, if you were to just keep writing the sequence, you have to write the 5th term first, then the 6th, 7th, 8th, 9th, 10th. A quicker way of doing this would be that you just use the formula, the nth term formula. So remember what the formula looks like. Tn, nth term is given by ar raised to power n minus 1. So you need 3 things for this. A, the value of the first term, ratio, and then the number of the term that you need, the position of the term that you're looking for. Let's write those things down here. We know the first term of the sequence is 2. What about ratio? You could take any 2 consecutive terms. For example, if I take the first 2 terms, ratio would be 6 over 2. Next over previous, that gives us 3 as the ratio. Now, if we are looking for the 10th term, we could say T10 is equal to A, which is 2, into R, which is 3, raised to power n minus 1, which is 10 minus 1. So it's 2 into 3 raised to power 9. You evaluate this on your calculator and see what that turns out to be. Okay, so let's try this. This turns out to be 39,366. This is the 10th term of this sequence. All right. So this is how you use the nth term formula in this case for a GP, for a geometric progression. Now let's talk about the sum of a GP. Sum of a GP. For sum of a GP, we have this formula Sn equals A into 1 minus R raised to power n divided by 1 minus R. This is the sum formula for a geometric progression. All right. So this is the next thing that you need to know about now. What does Sn stand for? It's the sum of the first n terms. All right. That's given by this formula, Sn equals A into 1 minus R raised to power n divided by 1 minus R. Now, let's take a couple of examples on this. Let's say you had something like this. You had a GP that looked like this. So you have a GP. It has terms 20, 10, 5, 2.5, and so on like this. All right, so the sequence keeps going on and on like this. Now, you know it's a geometric progression. So what you can do is you can find the ratio and the first term. The first term is 20. That's pretty straightforward. Now, for ratio, take any 2 consecutive terms. Let's say if I take 20 and 10, now divide the next by the previous. Okay, so this becomes 10 over 20, which gives you 1 over 2, or you could say 0.5. It's an exact decimal, so you could write it in decimals as well, and that's okay. Ratio is 0.5. If it was not an exact number, then it would have been better to write as a fraction. For example, if it was 2 over 3, you could not write this as an exact decimal. It would have been 0.6666 and so many zeros, so many sixes after that. So it's better to write that as 2 over 3. But in this case, this was an exact number. 10 over 20 is 0.5. It's okay to write this in decimals as well. So this is the value that we're getting, R equals 0.5. Now, let's say we were interested in the sum of the first 10 terms. Sum of the first 10 terms of the sequence. Now, how do we think about this? You could just use the formula. Sn is A into 1 minus R raised to power n divided by 1 minus R. This is what sum of n terms looks like. All right. Now, all you have to do is input values in this. N is 10. We're looking for S10. The value of n is 10. We have A is 20, into 1 minus R raised to power n. What's R? R is 0.5. Raised to power n, the power is 10, whole divided by 1 minus 0.5. And now you just evaluate this on your calculator. You could do it directly as well. So once you've written the step, it's okay to write down the answer directly. Make sure that you have a calculator that has fraction button in it. If you don't have fraction button on your calculator, please make sure that you change it, upgrade it. Otherwise, you'll have to use a lot of brackets, and there's a very high probability you would end up doing some mistake in that. So use fraction button properly, put this whole thing on your calculator if you want, and you'll get the result. Okay, so in this case, I am getting 39.96 from this. That's the sum of the first 10 terms of the sequence. All right, let's take another example. Let's say you have a GP that looks like this. You've got values 4, minus 12, 36, minus 108, 324, and so on. Now, this is also a GP. This is also a geometric progression. But now, if you were to write down the first term and the ratio, what would they be? A equals 4. What about ratio? Ratio in this case turns out to be negative. So it would be minus 12 over 4, and that gives you R equal to 3. Sorry, R equal to minus 3. So sometimes you could have a negative ratio as well. And whenever you have a negative ratio, you're always going to have numbers which are alternating like this. Right? So you'll have one number positive and then one negative, one positive, one negative. That's what is always going to happen if you have the ratio negative. Okay, because you'll keep multiplying with a negative sign, so it becomes positive once and then it becomes negative again, and so on. So these terms are going to have different signs alternately like this. All right, now in this, if you had to find anything in particular, let's say you were looking for the sum of the first 6 terms. How would you do that? A, which is 4, into 1 minus R. Now you've got to be very careful how you're inputting values here. Remember, the formula is R raised to power n. What's the ratio? Ratio is minus 3. So you have to put minus 3 in brackets and then raise that to the power 6 like this. So this minus 3 whole thing should be in brackets, and then you should have your power on top of that like this. Divided by 1 minus R, that's what you have in the formula, 1 minus R. Again, R is minus 3, so it becomes 1 minus minus 3. And now you could evaluate this and see what this turns out to be. So you have 4 into 1 minus minus 3 raised to power 6 in the numerator. In the denominator, you've got 1 plus 3, which is 4. 4 and 4 get cancelled. You can just evaluate what is left after that and see what that results in. Okay, so let me just try that. This is minus 728. All right, this is the sum of this GP that we end up getting. All right, now a couple of more things related to this. We've talked about the term formula of a GP. We've talked about the sum formula for the GP. All right, now in a lot of situations, you will have some kind of scenario given, and you'll have to figure out yourself whether it's an arithmetic sequence or a geometric sequence. Now, keep this in mind. Whenever you have a percentage increase or a decrease, this is always going to be a geometric progression. Okay, whenever you have percentage increase or decrease, this is always going to be a geometric progression. So for instance, if you had a set of numbers which you were increasing by 15% every time, What that would mean would be, if the first number is, let's say, 10, the next would be 11.5. That's 15% of 10 added to the previous term, right? So it's 15% more than the previous term. Similarly, the next term after that would be 11.5, and then you add 15% to that. That's going to be 13.225, and so on. So this is always going to be a geometric progression. And the problem would be, how do you find the ratio of this sequence? One idea is you could write down a couple of terms. So if the first term is 10, for instance, and the next term is 11.5, you could just have two terms like this, and you could find the ratio by dividing the next term, which is 11.5, by the previous term, which is 10, and that would give you the ratio directly, and that's going to turn out to be 1.15 in this case. That's the ratio. There's another way of thinking about this, that you could just look at the percentage and write down the ratio directly from that. Now, how does that work? If you were increasing something by 15%, let's say, what that means is, if you had 100% originally, right? So whatever was the original number, let's call that 100%. What you're doing is you're adding 15% to that. Okay. Now, what does that become? That becomes 115%. So every next value is 115% of the previous value. Now, if you were to just write this thing in decimals, remember how we used to write percentages in decimals? This means 115 divided by 100, and that gives you 1.15. That is going to be your ratio. So your ratio is 1.15. Similarly, if you had, let's say, 8%, how would you, 8% decrease, let's say? What does this mean now? If the original was 100%, you're subtracting from that 8%. What are you left with? You're left with 92%. So every next term is 92% of the previous term. What does the ratio turn out to be in this case? Just convert this thing into decimals. 92 over 100, which is 0.92. That is what your ratio is going to be. Similarly, if you have 10% increase, let's say, just another example, that becomes 100% plus 10%, and that results in 110%. If you write this in decimals, that is going to be 1.10, or you could say just 1.1. That's the ratio in this case. All right. So whenever there's a percentage increase or decrease, you can figure out the ratio like this. You can do this in your head as well. 15% plus 100%, that's 115. Let's just divide that by 100. That's 1.15, and that is your ratio. All right. So that's all that you have to do. Add 100%, convert that number to decimals, and you'll get your result. Okay. So whenever you have a percentage increase or a decrease, you have to remember this is always going to be a GB. All right. Now, let's talk about another case that you have, similar to what we did in arithmetic progressions as well. In a GP, if you have three consecutive terms given, so let's say you have a number which is -2, and then you have -6, and then you have not like this. Let's change this slightly. Let's say you have -4, then you have x, and then after that you have -36. Now, how do you figure out the value of x? These are three consecutive terms in a GP. This is term 1, this is term 2, and this is term 3. So you know three consecutive terms in the GP. All right, -4, x and minus 36. What we can do is, since it's a GP, since it's a geometric progression, that means the ratio of the consecutive terms should be equal. So if I were to do T2 divided by T1, which would be x over minus 4 in this case, next term divided by the previous term, that should equal T3 divided by T2, which is minus 36 divided by x. All right, if you cross multiply now, that gives you x squared equal to minus 36 into minus 4, and that gives you x squared equal to 36 times 4, that's 144. Now, in this case, actually, this information is not quite enough, because in this case, there is a possibility of having both x's. So yeah, so you could say there are two possible values of x in this case. It could be plus 12 or minus 12. Both of those possibilities are there in this case. So you could have one sequence which looks like this: minus 4, minus 12, minus 36. This is also going to be a GP. This is a GP with ratio 3. You could also have this GP minus 4, 12, minus 36. This is a GP that has ratio minus 3. So these both possibilities exist in this particular example. All right, because in this case, the middle number could be 12 or minus 12. Both of those cases are going to give you a GP, a geometric progression. Okay, so in general, if you have 3 consecutive terms of a GP given, let's say you have A, B, and C, what you can do is, remember what we did in this example, we said divide the second term by the first term, and then the third by the second. They should both give you the ratio, hence they should be equal. In this case as well, you could think of it like this. You could say ratio could be calculated as B over A and also C over B. So from this, you get this equation, B over A equal to C over B. So if any one of A, B, or C were missing, you could find that value. All right, so if you have 3 consecutive terms of a GP given, this is how you can relate them. If there's any one of A, B, and C missing, you could find them using this equation. All right, so this is these are the different things that you need to know about the geometric progression. Now, in the next class, we are going to do some practice questions based on all of these concepts that we have done until now. And then there's one thing that is left in this topic in terms of concepts, and that is sum to infinity of a GP. All right, so we'll do that after doing some practice questions on these concepts first. So what have we done until now? We've talked about term formula for an AP, some formulas for an AP. We have 2 formulas, one here and another here. And then we've done some variations of them and examples of them. Then we've done 2 formulas for a geometric progression. Geometric progression is defined by A and R, first term and ratio. This is the term formula, and this is the sum formula. All right, and then again, we've done some examples and talked about this particular scenario, percentage increase or decrease, that it's classified as a geometric progression. All right, and then we did some more examples in this as well. So this is what we've done until now. In the next class, we will be doing some practice questions, inshallah, and then do the last concept, which is sum to infinity of a GP. All right, that's it. I'll see you again tomorrow. Allah Hafiz.